Okay, so last time we were cut off doon sa result, which is what we call as the intersection theorem. The intersection theorem tells us that if you have a bunch of um, subgroups, no, if this is a collection of subgroups, is a collection of subgroups of a group G, of course, then we were able to prove that the intersection of these subgroups will still be another subgroup, no? Is again a subgroup of G. And furthermore, we have remarked that if H and K are subgroups of G, then in general, H union K may not be a subgroup, may not be a subgroup.
Asa man? Ah,
Pakimute yung mic. Okay. It may not be a subgroup of G. So, ang pagiging subgroup na retain kapag when you take intersections, while for union, mag-iingat kayo na hindi ang union ng dalawang subgroup may no longer be a subgroup. Um, so let's continue from at this point. So I think this time I'm going to introduce another concept. So here, G is a group and A is a fixed element in G. So in at this point we're going to consider the set denoted by C of A. Ang basa natin diyan C of A. Na ano nan laman ng C of A? Ang laman ng set na C of A is it is the set of all elements X in G where AX is equal to XA. Hindi ba in general groups need not have a commutative operation. So in other words, this equation may not be true all the time. No? So this set consists of those elements X of the group that makes this equation true. In other words, this set consists of all the elements that commute with A. No, parang paano mo masasabi kung nandito ka sa set na ito? Ang membership criterion dapat nagko-commute ka with A. When we say nagko-commute with A, it commutes with A, it means to say that if X commutes with A, meaning A times X must equal X times A in a group. So in other words, this is really a special occasion. Before I continue, take note that if G is abelian, anong masasabi natin sa laman ng C of A? Just in case the operation is really commutative, then this equation is always true for any X, right? So C of A this time consists of the entire group G. No? Kasi kapag nga naman abelian yung group, yung operation may commutative. So in other words, this equation will be true for any X. So the elements of C of A will be all of the elements of G. Naintindihan niyo ba tong remark na ito? Why is this true? Okay. So ano bang gagawin natin dito? No? Why do we need to consider the elements that commute with an element? No? The truth is, no, the reason why I am interested with this particular set is because we can construct a subgroup out of the element A by considering the elements that commute with A. Kumbaga, pag kinonsider mo lahat ng mga nakikipag-commute kay A, they form a subgroup. Yun nga yung subgroup na ang notation natin ay C of A. So, first we will prove that this is a subgroup. So, I'm going to stick with the three-step test. Na kasi sabi ko nga sa inyo, even though we have the one-step subgroup test, normally I still do the three-step kasi yun yung parang damang-dama mo na subgroup talaga yung isang set. No? First of all, tingnan nyo yung identity element when it is multiplied to A, whether to the right or to the left of A, it gives you A. So in other words, AE is equal to EA, where E is the identity. Therefore, because E commutes with A, E is an element of C of A, which also shows that C of A cannot be empty. No? Laging may element yung set na ito. The next step is to prove closure under multiplication. So to do this, we will pick two elements X and Y from C of A. In our mind, what we wanted to show is that the product XY must be in C of A. Kaya lang, ano bang qualifying property para mapunta ka sa C of A? The qualifying property, dapat magko-commute yung product with A. So, kaya nga ang unang step ko is to consider the product XY and I want to multiply it to the right of A. No? Let's look at what will happen. Applying associative property, you can see that I can write it as AX times Y. Now, because X is an element of C of A, AX will equal XA because X commutes with A. Now, again, applying associative property in the group, you see that that's X times A times Y. And because Y is another element of C of A, it commutes with A. So I can rewrite A times Y as Y times A. And finally, applying associative property once more, I get the following, XY times A. In other words, what happens in the end is that the product XY commutes with A, no? Which implies that the product XY belongs to C of A. And therefore, closure property for C of A has been established. Did you get that? Did you get the second bullet? Okay. Let's continue. What's the third thing to check to prove that C of A is a subgroup? Anyone? Ano yung huling-huling kailangan nating i-check to prove that C of A is a subgroup? Ano na lang natitira?
Close for inverse.
Very good. Closure for inverse. And by that, we mean that if we select an element X in C of A, we must show that X inverse as an element of the group G, no, must still be in C of A. So to prove that, we will begin with A times X inverse. I needed to show in the end that this will equal X inverse times A para masabi natin nagko-commute kay A, given the fact that X commutes with A already. So how do we do that? The trick is to consider the multiplying A inverse times A on the right. No? You know very well that A inverse times A is the identity, and multiplying the identity will not do anything to the product. Right? So, on the right, mag-multiply ako ng A inverse times A. So, I can group these two together. No? If I group those two together, you see by the shoes and socks property, the product of the inverses X inverse A inverse actually equals the inverse of the product AX. Do you get that? Naintindihan niyo ba yon? Shoes and socks property natin yon. And then, because X already commutes with A, X commutes with A, the product AX can now be written as XA. And applying the shoes and socks property once more, we will get A inverse, X inverse, A. And on the left, you will see the product AA inverse, which equals the identity, and therefore, that cancels out. Ang maiiwanan ay X inverse times A. So what happens in the end is that whenever we multiply X inverse to the right of A, no, ang nangyayari, parehas lang siya when you multiply X inverse to the left of A. Meaning to say, X inverse commutes with A, so X inverse is an element of C of A. All of these bullets prove one thing, no? It proves that C of A is an element, is a subgroup of the group G. By the way, this subgroup is not just a subgroup na randomly naisip ko lang, no? In group theory, this plays an important role, kaya meron siyang pangalan. Ang tawag natin sa subgroup na C of A is actually the centralizer of the element A. So in group theory, when you hear the word centralizer of an element, it is the subgroup consisting of those elements that commute with the given element A. No, kapag sinabing what is the centralizer of A? Ang laman ng centralizer yung mga nakikipag-commute with A precisely. Did you understand? Anong alam natin sa centralizer? It will always be a subgroup. Kung baga, tinuturuan ko kayo dito, kapag meron akong element, how do we construct a subgroup out of that element? So one way is to consider the centralizer or the elements that commute with A. Okay? Ito na nga, sinabi ko na ito kanina sa previous slide that if it happens na G is abelian, walang masama. And when that happens, yung C of A mo is just the entire G. No? Kasi lahat makikipag-commute with A. Kaya ang centralizer ng kahit na anong element is all of G. I have here an example, but this time this is a challenging example because we know very well that this group is a non-abelian one. As you can see, no, if I draw this diagonal line, you see that elements above need not be reflected below. For example, ito mu2, ito mu3. Although they are symmetric about the main diagonal, they are not equal. So meaning to say that means, halimbawa, ang mu1 rho 2 is not the same as rho 2 times mu1. Hindi sila parehas. So in other words, this group is really not abelian. Okay? If you can recall, these elements are the 6 bijections from the set 1, 2, 3 to itself. Naalala nyo ito, no? So for example, how do we list down the elements of the centralizers? When you say the centralizer of row 1, hahanapin natin yung mga nakikipag-commute with row 1. So don't worry, palaging mayroong element dyan na makikipag-commute kay row 1 kasi sure tayo na yung identity will commute with row 1. Now, aside from row 1, by looking at the table, what other elements commute with row 1? How would you know this? Sige nga, can you give me one? Aside from the identity, what other elements commute with row 1?
Row 2.
Row 2, no? Kasi yung row 2 times row 1, row 2 times row 1, that's the identity, and row 1 times row 2, that's the identity as well. Did you understand? So, row 2 is in the centralizer of row 1, but you forgot an important element. Siya dapat yung unang-unang maisip niyo maliban sa identity. You know kung sino yun? Bago niyo maisip si row 2, dapat si row 1 muna. Very good si Frank. Si row 1 muna ang unang-una kasi ang row 1 times row 1, pag baligtarin mo man silang dalawa, that's still row 1 times row 1. It will not matter. Composition pala yung operation natin dito, ha? Okay. So si row 1, maliban kay row 1, we found out that row 2 also commutes with row 1. Halimbawa, does mu1 commute with row 1? Si mu1 ba? Mu1 nagko-commute with row 1? You check. Tapos row 1, mu1. Parehas ba yung nakikita nyo? Hindi. So mu1 is not an element. How about mu2? Yes or no? Is mu2 an element of the centralizer of row 1? By looking at the table? Yes or no? Hindi rin. Yes, okay. How about mu3? Mu3. Hindi rin, no? So, I think we're done because there are just 6 elements. We can just check one by one. So in other words, this set consisting of 3 elements form a subgroup. In fact, kapag titignan nyo talagang mabuti, no? Halimbawa, tignan nyo yung table mo that consists of ID row 1 and row 2 only. Kung makikita nyo yung table na ito, talaga namang closed siya under multiplication. Remember, kapag finite ang group, to check a subgroup, you just need to check for closure. As you can see, that subset is really closed under function composition. Wala naman lumabas dito na other elements like mu, no? Ang lumabas lang dito, row 1 or row 2. At yan ay group din, di ba? In fact, yung group na ito, if I may write here, is actually isomorphic to which group of order 3? To which group of order 3 is this isomorphic to? Pag group of order 3, anong group ang una niyong maaalala dapat? Sige nga, sinong group of order 3 isomorphic dito? Hindi nyo maisip? Very good, si Michelangelo. It's isomorphic to the group Z sub 3 under addition. You know why? Kasi ang Z sub 3, when you construct the table, 0, 1, 2, 1, 2, 0, 2, 0, 1. As you can see, the pattern here prevails in this table. No? Parang ito yung 0, 1, 2, 1, 2, 0, 2, 0, 1. Did you understand? That's why this is isomorphic to Z sub 3. Okay? Okay. Can we now check the centralizer of mu1? So what are the elements? Of course, ID. What else? mu1. No? What else? Si row 1 ba nagko-commute kay mu1? Kanina na-check natin hindi. Si row 2 ba nagko-commute kay mu1? Si row 2 ba nagko-commute kay mu1? You can check. Row 2 mu1. Ito yun. mu1 row 2. Ito siya. Pares ba? Hindi. No? How about si mu2? Si mu2 ba ay nagko-commute with row 1? Check natin. mu2 row 1, mu1 row 2, that's row 1. mu2 row 1, that's row 2. Okay? Hindi rin. How about mu3? Nagko-commute ba kay mu1? Tingnan natin. Ito mu3, row mu3, mu1. Check mo yung ka-symmetric na hindi parehas. Kaya, hindi nagko-commute. So, sino nagko-commute kay mu1? Dalawa lang, no? Dalawa lang, no? Si mu1 lang, tsaka si ID. Siya lang ang nakikipag-commute sa sarili niya. Hindi siya masyadong friendly. Ang friendly lang yung class president. Ang class president, which is the identity, is friend na lahat, no? Siya yung pinaka-paborito ng buong klase. And this subgroup is actually, needless to say, it's isomorphic to Z sub 2. Kasi kapag tatakpan mo lahat, iiwanan mo lang yung ang Z sub 2, by the way, ito yung binary group, no? 0, 1, 1, 0. Okay? Tapos, kung tatakpan mo lang, kung iiwanan mo lang pala yung ID tsaka yung mu1, burahin mo lahat ito. No? Burahin mo to. Kung may iwanan yung table mo, yan yung 0, 1, 1, 0. Parang ganun. Kaya, isomorphic siya sa Z sub 2. When you can get the centralizer of any element, you will always get a subgroup. That's the idea of this concept. So at this point, I'm now going to define the center of a group. Meron tayong tinatawag na center of the group. No, for any group G, there is always what we call as the center. Ano naman ng center ng group? Sa Tagalog, gitna, no? The center of the group is denoted by Z of G. Z stands for centrum, the Latin, yung Latin counterpart ng word na center. Centrum, whatever. I don't know. The center of the group G, Z of G, is basically just the intersection of all the centralizers. Ibig sabihin, pag kinuha mo yung centralizer ng lahat ng elements or ng bawat elements, just take the intersection of these subgroups. We know that that will always be a subgroup, correct? Okay? Tapos, Yung subgroup na yun is what we call as a center. So technically, anong laman ng center? The element of the center is the set of all elements G, X, and G that what? Commutes with all the elements of G. No? In other words, yung AX equals sa XA for all A and G. Kasi remember, this is an intersection. Ang intersection, napapalitan ng for all. Okay? Kumbaga, yung mga elements dito, hindi lang nagko-commute sa isa, no? Nagko-commute pa sa lahat. Did you understand? Parang, imaginein mo yung centralizer ni A. Ito yung mga friends ni A. Na? Halimbawa, bawat isa sa klase, about isa sa group, may kanya-kanya mga circle of friends. Yung intersection ng circle of friends na to, yun yung center. So, parang you can imagine, ito yung circle of friends ni A, ito yung circle of friends ni A2, ito yung kay A3, ito, etc. If you take that little intersection, wag nyo i-expect na maraming elements yung center, no? Kasi the more elements you have in the group, the smaller this subgroup. Diba? Yun yung center, yung intersection niyan. And of course, dahil ang class president friend ng lahat, siyang unang-unang nandun sa center, di ba? Actually, you don't need to check that this is a subgroup kasi we have proven that this is already a subgroup as an intersection of well-known subgroups. Now, as an exercise, kinuha ko yung centralizer kanina nung row 1 tsaka nung mu 1. Am I correct? Yun ba yung kinuha ko kanina? Diba? Row 1 at mu 1. So, on your seats, kunin yung centralizer ng natitirang elements. Okay? Apat lang naman yun. And then take the intersection of those six centralizers ang titignan ninyo. Kunin yung intersection. Yung intersection will be the center of the group. Tapos, tatanungin ko kayo later kung ano nakuha niyo sagot. Okay? Can you manage this on your own? Kaya niyo bang gawin ito? Hindi na mahirap, no? Just look at the table of S3 once again. Kung nagsusulat kayo, dapat meron kayong table nito sa sa mga notes nyo. Okay? What are the elements that commutes with everyone? Ano kaya yun? Siyempre, maliban sa identity, sino pa kaya? So, yan, aalamin ninyo. So, what I have just shown you is a way to construct subgroups out of a given element, right? Okay. So, there are actually more convenient ways. Kasi ang paghahanap sa centralizer, hindi madali, no? Especially when the group is, when the group is big. Ito nga lang group with 6 elements, medyo matagal hanapin ng centralizers ng element, no? Right? So, tuturuan ko kayo ng mas convenient na paraan to construct subgroups out of the elements, no? Ganito, mamaya. So, let's say, meron akong group. Ito, dodrawing ko siya. Ito si group G. Okay, ito yung si G. Tapos meron ako ditong subset na S. Pagawin natin siyang ganitong itsura. Para mukha siyang S talaga. Kunwari yung si subset S. Okay, so this is the subset S. Okay. In general, pag kumuha ka ng subset, maaaring hindi yan subgroup, right? Correct? Now, tingnan niyo yung sinasabi dito. Kunin niyo lahat ng mga subgroups ng G na nagko-contain kay S as a subset. Ibig sabihin, kung yung subgroup kino-contain si S, kasama siya sa bilang, no? Parang kung isi-census natin lahat ng mga subgroups, sino-sino sa inyo ang mga nagko-contain kay S? For example, there may be a subgroup H1 right here, no? There may be another subgroup that will contain S as a subset. There may be another subgroup H3 that contains S. Do you understand anong gagawin natin sa collection na to? So yung collection mo, kunwari, 3 lang. Yung subgroups na nagko-contain kay S. Titignan natin yung 3 yan. Anong gagawin ni Sir? Ang gagawin ni Sir doon sa 3 yon, I will take their intersection. Their intersection is the subgroup. The one shaded in blue. As intersection of subgroups, this is also a subgroup, correct? The blue one, correct? The blue region. Can you imagine that? And because each one contains S as a subset, ano mangyayari? That intersection is a subgroup that contains S as a subset once again. And in fact, because it is the intersection, it is the smallest subgroup of G that contains S. Kasi you might be curious. Ano ba, meron akong set. Chinek mo, gumamit ka ng subgroup test. Nalaman mo, ay hindi siya subgroup kasi it violates a particular action for a subgroup. No? May na-violate siya dun sa 3 test natin. So, hindi siya subgroup, subset lang siya. Ang pinaka-natural question to think about is, ano yung pinakamaliit na subgroup na nagko-contain sa kanya? In other words, kasi kung titignan niyo yung subgroup axioms, yung 3, ang dahilan kung bakit ka mag-fail to become a subgroup ay 3 things. Number 1, wala yung identity sa kanya. Pangalawa, there may be elements in the subset whose product fails to belong to the same subset. That's the second case. The third case, na pwedeng may element ka na ang inverse ay wala doon sa subset. So, yun yung 3 dahilan bakit hindi ka magiging subset. In short, ang main reason why a subset fails to become a subgroup is because may mga elements na kulang sa kanya. So what we're doing when we're taking the smallest subgroup containing S is we are actually adding to S the elements that it needs to become a subgroup. Did you understand? Ang ginagawa natin pag kinukuha natin yung smallest subgroup containing S, maliban sa kinukuha natin yung intersection ng mga subgroup na nagko-contain kay S, what it actually contains are the elements that we wish to be in S in the first place para hindi sana nag-fail yung subgroup test. Naintindihan niyo yung kwento? Ito yung mga elements na kulang. Tignan natin yung diagram ni Sir. Teka na, namatay iPad ko, sorry. Tignan natin yung diagram ni Sir. Nakita niyo yung S yung puti. Yung H, yung intersection ng mga subgroups, yung blue. Yung mga elements na nasa blue na wala sa S, ito yung mga elements na kulang, mga nawawalang elements ng S para subgroup sana siya. Naintindihan nyo? Naiintindihan nyo ba yung sinasabi ko? Kasi maraming, kapag face-to-face na klase, maraming nahihirapang unawain itong idea na to. But yeah, lalo na siguro online. But I hope some of you can understand. Ang tanong dito, anong elements ng set na ito? Anong group, yung subgroup na ito? Ito yung notation niya na ito yung pinakamaliit na subgroup that contains S. So ano magiging elements nito? May sagot na tayo, sinagot na ni Sir. Ang sagot dito, ang laman nito ay si S mismo, tsaka yung mga elements na kulang para maging saktong subgroup siya. Did you understand? Yung mga nawawala, paano mo ba ma-check yung mga nawawala? Pwede ka mag-multiply ng mga elements. Kasi nag-check ka ng closure. Ano ba? Check mo muna yung identity. For example, baka wala sa S. Pag sinama mo yung E dyan sa S, nandiyan yung E. Nandito yung E. Maaring wala sa S pero nandyan sa subgroup na yan. What else? Halimbawa, may 2 elements ka. Minultiply mo together. Wala doon sa S. Isasama mo siya dito. Lahat ng mga kulang, may element ka, tapos yung inverse, wala dyan sa S. Sama mo ulit yun. And the other combinations, kasi hindi lang naman dalawang products ang meron. You could have several elements at the same time, multiply mo together, tapos wala yung product sa S. Isama mo lahat yan. In fact, halimbawa, kung halimbawa si S, dalawa lang ang elements, A and B, anong laman ng subgroup na ito? I think smallest subgroup containing S, no? Ganun natin yan tinitignan. Ang laman yan, mga products ng mga A and B na hindi nyo ma-imagine. For example, AB, AB, AB. Diba? Ano pa? Nandiyan yung AB, A squared, B inverse, AB, A inverse. Ano pa? Nandiyan yung A to the 34, B squared, AB to the negative 3, A to the negative 29. Lahat ng mga products na ito, nandoon sa subgroup na ito. Lahat ng mga possibilities, no? Na may isip nyo. And so, nakita nyo and so on. Kasi the truth is, I cannot list down all of those products that can be made out of A and B. So technically, ang laman nito are the combinations of products of powers of A and B. Did you understand? Kasi all of this will guarantee closure for this one. Lahat kasi ng mga possibilities, kailangan mong i-check. Tingnan mo, baka yung A cubed times B squared times A inverse wala sa S. Kung wala sa S yun, ilagay mo siya dito. Kasama siya dito. In other words, in English, ang laman ng subgroup na ito ay yung mga finite products of integer powers of the elements of S. Did you understand? Ayan, in-underlinean ko for you. Anong laman ng subgroup na ito? Ang laman ng subgroup na yan, yung mga finite products of integers, powers of the elements of S. Naintindihan nyo? Halimbawa, tuturuan ko kayo. Punta tayo ulit sa S3. Halimbawa, dito, yung sa number 1, ang S ko ay 0,1 lang. Ang laman ng S ko, 0,1 lang. Isang element lang siya. Dahil isang element lang ito, ano lang yung mga isasama natin sa subgroup na ito? Ang isasama lang natin ay mga finite products ng mga integer powers ng mga elements ng S. At this time, yung S mo, isa lang ang laman. So, in other words, ang laman nito, yung mga integer powers ng row 1. Kaya lang tingnan nyo, halimbawa, if I take, of course, row 1 to the 0, that's the identity by definition. Row 1 to the 1, that's row 1. If I take row 1 squared, from the table, ano yung row 1 squared? Row 2. So, si row 2 kasama sa subgroup na yan. But now, as you can see, if I take row 1 cube, ano mangyayari sa row 1 cube? Anong row 1 cube? Anong sabihin na row 1 cube? Row 1 squared times row 1, kaya identity. Nakita niyo bumalik na sa identity? So in other words, row 1 has order 3 kasi bumalik ka na sa identity for the first. Kaya importante yung order. Alam niyo kasi mangyayari, if you keep doing the powers, ano mangyayari lang? Paikot-ikot ka lang sa apat na to. ID, row 1, row 1 squared, ID, row 1, row 1 squared. Kahit anong powers mo. In fact, if you take the inverse of row 1, anong inverse ng row 1? Anong inverse ng row 1? Ha? Row 2. Anong inverse ng... so ano yung row 1 to the negative 2? Pag sinabing row 1 to the negative 2, that's row 1 times row 1. Row 1 inverse times row 1 inverse. Yun yung sabihin yan, di ba? Dalawang row 1 inverse. So in other words, dalawang row 2. Anong row 2 squared? Row 1. Tama? At ang row 1 to the negative 3, kasi ito yung row 1 cube to the negative 1 or inverse of row 1 cube, identity na lang yan. So nakita nyo, walang lumalabas na bago. Paikot-ikot ko lang sa ID, row 1, row 2, ID, row 1, row 2, ID, row 1, row 2. Ikot-ikot lang yan. Kaya ang laman nito, tatlo lang. Hindi totoong infinite. Kasi yung mga products mo, paulit-ulit lang. Kasi this time yung mga elements mo, finite ang order. Kaya ito naman, ID, row 1, row 1 squared, which is row 2. Wala nang iba. In fact, ito rin yung centralizer ni row 1. Nagkataon. Na? How about new one? How about the subgroup? Ay, hindi ko nasabi yung pangalan nito, no? Ang tawag pala natin dito, this is what we call as the subgroup generated by S. Oh, alam niyo naman kung bakit siya subgroup generated by S. Kasi yung mga elements niyan, na-generate natin from the elements of S. So pag sinabi ko sa subgroup generated by S, ito yung mga subgroup, pinakamaliit na subgroup na nagko-contain kay S. How about the subgroup generated by mu1? As you can see, if I take the square of mu1, anong lalabas? Anong square ng mu1? Krisha.
Identity.
Very good, identity. So as you can see, ang mu1 ay may order na 2. Bumalik ka na kagad na identity after a power of 2. So in short, iikot-ikot na lang siya ng dalawa-dalawa, no? mu1 ID, mu1 ID, mu1 ID. Pag nilista mo yung powers niya, dalawa lang. Kaya ito lang ang lalabas. Again, nagkataon, ito lang din yung centralizer ni mu1. Okay? Pero halimbawa, ganito na. Paano na ito? Dalawa na yung elements. Naku, ang dami niyan. Ganito. Ano naman ng subgroup na to? Lahat ng mga powers ni row 1, lahat ng mga powers ni mu1, tapos yung mga possible products nila, lahat-lahat. No? Halimbawa, ano yung mga powers ng row 1? So, syempre kasama itong dalawa. Okay? Ano yung mga powers ng mu1? mu1 in identity lang. Tapos, isasara mo na ba yan? Not yet. I-check mo pa yung mga possible products ng mga elements. Basically, ang gagawin mo, kukuha ka ng isa sa mga powers ni row 1 at isang power ni mu1. Ano ba? Check mo yung row 1 times mu1. Ano yung row 1 times mu1? mu3. So, sabihin dapat si mu3 nandito din. Check mo naman yung row 2 times mu1. Kasi dapat closed ang subgroup. Si mu2 dapat kasama rin. So, in the end, ano nangyari? The subgroup generated is just all of S3. Did you understand? Indeed, no? Ito, no? Itong mga equations na ito, pinapakita how we can express every element of S3 as a product of row 1 and mu1. Na? Si ID ay row 1 to the 0, si row 1 ay row 1 to the 1, no? Nakalimutan ko na sulat yung 1 doon. Si row 2 ay row 1 squared, si mu1 ay mu1 to the 1, si mu2 ay row 1 squared times mu1, at si mu3 ay row 1 times mu1. In other words, lahat ma-generate mo out of row 1 and mu1. Kaya nga ito ay S3. To say this in English, parang sinasabi natin that row 1, mu1 is a generating set, no? This is a generating set for S3. Ibig sabihin, kailangan ko lang pala ng dalawang elements ng S3 para ma-generate yung buong S3. May tanong ako sa inyo. Ang question, can S3 be generated by a single element only? Kasi kaya siyang i-generate ng dalawa. Ang tanong, kaya ba siyang i-generate ng isa? Diba, syempre, ang ma-generate ng ID lang. Ang ma-generate ng row 1, kanina kinompute natin, ang ma-generate ng row 1, 3. Ang mag-generate ng mu1, dalawa. Ilan kaya mag-generate ng row 2? 6 kaya mag-generate niya? Actually, hindi. Kasi ang mag-generate ng row 2 ay yung mag-generate lang din ng row 1. Kasi square siya ng row 1 eh. Di ba? Si mu2 mag-generate niya ba yung buo? Hindi. Kasi si mu2 order 2. Kagaya ng mu1. Si mu3 order 2 lang din. Kagaya ng mu1 at mu2. Magkakauri si mu1 at mu2 at mu3, di ba? Yeah. So in other words, none of the elements can generate the entirety of S3. In other words, the minimal set that can generate S3 is a set with 2 elements. And we have found one of those generating sets. And one of the generating sets possible with 2 elements is the set containing row 1 and mu1. Did you understand this example? Okay. Ba't ko ba tinanong yung tanong na can S3 be generated by a single element? Kasi in the next slide, we will be interested with the subgroups that can be generated by a single element. Pag ang subgroup na generate ng isang element lang, these subgroups play an important role in group theory, as you will see in the next few slides. May specific na role silang ginagampanan. Halimbawa, ang S mo, isa lang ang element. Let's say A. Okay? Ano yung subgroup generated by S or the subgroup generated by A? Ang laman na ito, according to our definition, ang laman niya ay yung mga integer powers ng A. Si E, for example, siya sa A to the 0, ito si A to the 1, A to the minus 1, A squared, A to the minus 2. Do you get the idea? Or in set notation, it's the set of all A to the N, where N is an integer. This subgroup, na hindi ko sinasabing, may sinasabi ba si Sir na infinite ito? Does it always follow na yung set na to infinite? Nagko-follow ba na infinite ito? Hindi, no? Kasi the truth is, there can be repetitions in this list. Kasi some elements will go back to some powers of elements will go back to identities. Kasi some of them will have finite orders, no? Okay. So, basically, this subgroup is the smallest subgroup containing A. Kapag ang subgroup mo generate ng isang element, we call it a cyclic subgroup generated by A. Mamaya ipapaliwanag ko bakit ginagamit natin yung word na cyclic for this type of subgroups. So anong gagawin mo to get the cyclic subgroup generated by an element? You simply take the integer powers of A. They will form a subgroup according to a previous slide. Well, hindi na kailangan gawin ito, pero I mean, you can still use the subgroup test to prove in detail that this set will form a subgroup of G. Kasi yung identity, for example, it's A to the 0. No? Ang product ng dalawang powers ng A by the loss of exponent is again another power of A. Integer power, I mean. Pangalawa, ang inverse ng isang integer power ng A is again an integer power of A. Kasi ang law of exponent natin, ganyan. Diba? Correct? O kaya nga yan ay subgroup. In fact, you don't even need to check. But just in case you were curious, yeah, there you go. So, halimbawa, let us describe all the cyclic subgroups of the additive group Z. So, when you say additive group Z, we're looking at the operation addition. Of course, pag iisa-isahin mo yung elements ng Z, totoo naman, sir, infinite yan, di ba? 1, negative 1, 2, negative 2, 3, negative 3. But then, this time, the group is additive. So when we talk about powers, or yeah, A squared, it's not really A times A. Ang ibig sabihin ng A squared sa context ng group na to ay A plus A. Addition tayo, hindi tayo multiplication. Although groups in general are written multiplicatively, but there are some groups that are additive in nature. So with that in mind, yung mga multiplicative notations nyo, i-convert nyo into additive. So halimbawa, kanina sa definition nakakita ka ng A squared. Hindi na yan A squared ngayon. Papalitan mo siya ng A plus A or 2 times A. No? 2A. Sa algebra, 2A ang sulat natin dyan. Instead of writing 2 in the exponent, we are writing it beside A. Ang tawag nyo nga dyan, numerical coefficient. Di ba? Instead of writing A inverse, ang ginagawa natin, sinusulat natin minus A. Instead of writing A to the negative 2, it's minus A plus minus A or minus 2A. Yun yung meaning niyan kapag nasa algebra ka, di ba? Kaya nga halimbawa meron kang A cube B, tapos may 3 ka dyan. Anong meaning niyan sa algebra? Sa algebra, ang meaning talaga niyan, tatlong A cube B. Tapos, ano yung sabihin ng A cube B? Ang A cube B is A, B. Did you understand? Yan ang meaning niyan sa algebra. Nagmumukha na bang algebra talaga yung subject natin? Mukha na siya abstract algebra. Kasi nung umpisa parang hindi naman algebra, di ba? So as you can see, the moment you study group theory or abstract algebra, you will never look at algebra the same way again. Kasi this time, you're studying algebra in a deeper perspective, no? So let's go back. Ito sa example natin. So powers here means repeated addition. So for example, what's the subgroup, the cyclic subgroup generated by 0? Or if I keep adding 0 to itself many times, will I get anything new? May makukuha ba akong bago if I add 0 to itself many times? Wala, di ba? So this subgroup is actually the trivial subgroup. Right? How about the subgroup generated by 1? Oh, syempre identity nandiyan kasi that's 0 times 1. 1 times 1 is 1. Negative 1 times 1 is negative 1. 2 times 1 is 2. Ang sabihin ng 2 times 1, dalawang 1 plus 1. Okay? Ang sabihin ko ng negative 2 times 1, ang sabihin ko nun, negative 1 plus negative 1. That's negative 2. Anong lalabas? Ang lalabas basically is all of Z. Mag-generate mo yung buong Z. Hindi kagaya ng S3 kanina. Yung S3, it is never generated by a single element. But Z can be generated by a single element. You see? Naintindihan nyo ba? O halimbawa, sino yung mag-generate ng negative 1? Mag-generate ng negative 1 if you keep adding it, syempre negative 2, negative 3, negative 4. Eh yung mga inverses pa ng mga yun, by closure for inverses, dapat si 1, 2, 3 nandun din. So makikita ninyo, ang mag-generate ni 1, yun din yung mag-generate ni negative 1. Okay? How about the elements that can be generated by 2? Syempre, 0 will always be there. Kasi 2 times 0 is 0. Ay, 0 times 2 pala. Nasa unahan yung numerical coefficient is 0. 2 is there. Anong inverse ng 2? Negative 2. Ano ang 2 plus 2? 4. Ano yung inverse ng 4? Negative 4. Ano yung 2 plus 2 plus 2? 6. Ano yung inverse ng 6? Negative 6. Ano yung lalabas dito? Ano yung lumabas? Yes, it's the set of even integers. In abstract algebra, this is denoted by 2z. Na? In abstract algebra, that's denoted by 2z. Do you notice this is also the subgroup that can be generated by negative 2? Na? Siya rin yung nag-generate na negative 2 because 2 and negative 2 are basically inverses. Do you agree? Do you agree? Okay. How about the subgroup that can be generated by 3? Ano naman lalabas dito? 0, 3. Anong inverse ng 3? Negative 3. Anong 3 plus 3? 6. Anong inverse ng 6? Negative 6. Anong 3 plus 3 plus 3? 9. Anong inverse ng 9? Negative 9. Etc. Ito naman yung mga multiples ng 3 or the set 3z. And as you can see, this is also the subgroup generated by negative 3. Aha! We can now find a pattern. So, when you are asked to describe all the cyclic subgroups of the additive group C, what are those? So, the cyclic subgroups of Z are the subgroups, of course, the trivial one, and the subgroup NZ, where N is a positive integer. When you say NZ, ito yung mga multiples ng N. Wala nang iba. Wala nang ibang cyclic subgroup, di ba? Yan lang lahat. Yung singleton 0, which is the one generated by 0. So, pag may positive integer na N ka, kunin yung mga multiples ng N. Yun yung subgroup generated by N. Did you get this example? And did you get my conclusion? Okay. So, may I just give the following as a remark? Kasi I don't think this is in the slide. Kasi na-observe natin ito eh. If G is a group, and A is an element of G, then the subgroup that is generated by A is the same as the subgroup that is generated by its inverse. Anong reason? Anong reason behind this? The reason behind this is because if you have an integer n, ang a to the n is a inverse to the power of negative n. In short, ang isang power ng a ay power din ng a inverse and vice versa. No? Pag meron kang power ng a inverse, that is also a power of a. Naintindihan nyo? Because of this laws of exponents, kung ano yung mga powers ng a, yun din yung mga powers ng a inverse. And when I say powers, I mean integer powers. Did you understand this? Tandaan nyo ito ha. Kung ano ma-generate ng a, yun din yung ma-generate ng inverse niya. This is a very important remark. And I want you to take this down sa notes ninyo. Okay? Halimbawa, we are now working in the additive group of Z sub 6. Z sub 6 consists of what? It consists of 0, 1, 2, 3, 4, 5. And we are working modulo 6. Okay. So what is now the subgroup generated by 0? Siyempre, ito yung 0 lang. Kasi 0 plus 0, no matter what you do, it will always be 0. Halimbawa, if you add 1 to itself, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5. As you can see, we have generated all of Z sub 6. In fact, the inverse of 1 is 5. Kasi ang 1 plus 5, 0. The inverse of 2 is 4. Because 2 plus 4 is 0. And the inverse of 3 is what? 3 itself. Kasi 3 plus 3 is equal to 0. How about the subgroup generated by 2? Aside from 0 and 2, what are in this subgroup? 2 plus 2, 4 plus 2, just keep on adding 2. 4 plus 2, 0. As you can see, dahil nag-0 na, isasara mo na kasi uulit lang tayo ng uulit. In fact, ang inverse ng 2 ay si 4. Ang inverse ng 4 ay si 2. Kaya ito'y sarado na talaga. Ito'y subgroup na. In fact, you can get a table for this subgroup 0, 2, 4. You will see that this is indeed a subgroup. And this subgroup is once again isomorphic to Z sub 3. Hindi ko lang needless to say. How about the subgroup generated by 3? 0, 3. 3 plus 3. Ay, order 3 yung 2, no? Ay, yung 3. Order 2 yung 3. Baligtad ako. O, tama rin pala yun. Order 3 yung 2. Order 3 yung... Order 2 yung 3. How about 4? Ito na. Actually, we don't need to work on the subgroup generated by 4. Kasi it will be the same as the subgroup generated by 2. As 2 and 4 are inverses in this case. Kaya ito ay 0, 2, 4 lang din. In fact, you can check. Tingnan nyo. Anong 4 plus 4? Of course, 8. Pero modulo 6, that's 2. Plus 4, if you add 4 to 2, you will now get 0. As you can see, these two sets are just really the same. Walang nagbago. Na? Nakuha nyo ba? And what is the subgroup generated by 5? It will be the subgroup generated by 1 because 5 and 1 are inverses and of course this is Z sub 6. Halimbawa, kung hindi mo napansin yun, ginawa mong dire-diretso, 0, 5. Anong 5 plus 5? 4. Plus 5. 3. Plus 5. 2. Plus 5. 1 plus 5. 0 na. As you can see, na-generate pa rin naman talaga lahat. Did you understand how to get cyclic subgroups? So lahat ng mga nakalista dito are subgroups. And they are cyclic subgroups because these are the subgroups which can be generated by only one element. Did you understand? In particular, may interesting tayong nakita dito. The subgroup Z sub 6 can be generated by actually a single element, no? It can be generated by 1 and 5, no? So I just want you to observe that C sub 6 can be generated by 1 or by 5. In other words, 1 and 5 are generators. Interesting, huh? How about, excuse me, pasensya, sinisipon si Sir. In the group C star, pag sinabing C star, ito yung group of non-zero real numbers, complex numbers. Tinatanggal natin yung zero kasi ang operation natin ay multiplication. Kasi ayaw natin magkaroon ng problema sa anong group action yung iniiwasan natin. Magka-problema kaya natin tinatanggal yung zero. Anong group action yun?
So inverse po.
Correct. Kaya natin tinatanggal yung zero because we don't want a problem about multiplicative inverses. So we're removing zero. So everyone gets their respective inverses. So we're happy. This is a group. In fact, this is an abelian group. If you look at the element I, you know the I, the imaginary number I. Sometimes in algebra, it's written square root of negative 1. But, you know, I don't use this notation. But, yeah, anyway. So, for example, if you take the square of I, what do you get? Negative 1. If you take the cube of I, you get I squared times I. So, that's negative I. Or you might want to write it as like this. If you take I to the fourth, what do you get? So this is I cubed times I. So this is minus I times I. minus I squared, that's 1. In other words, bumalik ka na ng identity. Ang identity natin dito, 1 kasi multiplication tayo. So in other words, uulit-ulit na lang yung apat na yan. Ano yung apat na powers? I, negative 1, minus I, tsaka 1. Paulit-ulit na lang tayo dyan sa apat na yan. Alam niyo na bakit cyclic? Alam niyo na bakit cyclic? Paulit-ulit lang. Did you understand? Bakit ito na yung apat na elements? I have just confirmed it by actually doing the multiplication, the powers of I. So, tatandaan nyo ha, pag nakakita kayo ng ganyan, it means the set of all integer powers of I, including the negative integers. Pero syempre, ang I inverse, ang I to the minus 1, 1 over I, ano lang naman yan? Pwede mong multiply I on both sides, I on both numerator and denominator, you can get I over negative 1. This is just minus I. So, kita nyo, ito lang ulit yun. Basta, kunin niyo lahat ng mga powers nyo, apat lang ang lalabas. If you draw the complex plane, alam niyo yung complex plane? Are you all familiar with the complex plane? Narinig niyo na yung the complex plane? Yung complex plane, parang Cartesian plane lang din siya. Pero, instead na, di ba may x-axis ka? Instead na y-axis yung pangalawang axis, tatawagin yung y-axis. Ibig sabihin, ito yung 1, 2, 3, negative 1, negative 2, negative 3. Dito sa taas, hindi ka maglalagay ng another real number line. Lalagay mo dito yung mga imaginary na I, 2i, 3i. Dito lalagay mo minus I, minus 2i. Okay? Para pag nagkaroon ka ng, halimbawa, 2 plus 3i, nasan yung 2 plus 3i? Nandito yung 2 plus 3i. Ito yung 2 plus 3i. So in other words, your complex numbers can be interpreted as the points in the Cartesian plane as well. Kasi kailangan mo yung dalawang real number to define a complex number. So halimbawa, nasan dyan si I? Ito si I. Si I take note, it's 0 plus 1i. Kaya parang ang coordinate niya ay 0, 1. Okay, so it's there. Yung minus 1 is here, minus I is there. So kung mapapansin nyo, kung ito yung complex plane ninyo, yung apat na powers ng I ay ito. Ito yung ito yung 1, I squared is this. At ito yung I cubed. Ang I to the fourth ay babalik na sa 1. So nakita nyo, there is a cyclic pattern. In square, cube, fourth power, fifth power, I. Sixth power, I squared ulit. And so on. At kung I to the negative 1, pabalik naman tayo. Ito yung I to the negative 1. Ito I to the negative 2. Diba? I to the negative 4. Negative 3. Tapos ito I to the negative 4. Pabalik naman yung ikot pag negative yung integer powers. Pero hindi lahat ng complex numbers, ganyan ang mangyayari. Look at the complex number square root of 2i. Okay? When you take the n power of the number square root of 2i, n power, di syempre, kukunin mo square root of 2 raised to n times I to the n. So ito yung 2 to the n over 2, I to the n. Alam natin yung I to the n, umiikot lang to na umiikot sa apat. Pero tignan nyo, meron multiplier dito na 2 raised to n over 2. So halimbawa, ang n mo for example, 2. So pag ang n mo ay 2, titingin ka sa direction ni negative 1 kasi ang I squared negative 1 eh. Diba? Negative 1. Sa direction ni negative 1, mag-multiply ka ng 2. In short, ito yung negative 1, di ba? Times 2 mo siya. Nandito yun. Ako niya, nandito yung square root of 2i squared. Habang lumalaki yung n, anong napapansin nyo dito? Habang lumalaki yung n, yung 2 to the n over 2, papalaki ng papalaki. Therefore, umiikot yung mga points dahil dito, pero habang lumalaki yung n, dahil ito'y papalaki ng papalaki, habang umiikot, ikaw ay getting farther and farther away from the origin. So if you list down the powers of square root of 2 to the I, you will see these blue points. Siyempre, nilitan ko yung grid para makita nyo yung sum of the positive powers. Okay? Nasaan dyan yung square root of 2i? Yung square root of 2i is... Where is it? I don't know. Where is that number? Okay. Teka, i-zoom ko sa inyo ha. Nag-zoom ba? Nag-zoom ba siya?
Yes po.
Okay. So ito, yan yung square root of 2i. At tawagin natin ito kunwari alpha. Para na may pangalan siya. Nasaan yung alpha squared? Yung alpha squared is actually this one. Ito, yung alpha to the 0, which is 1. Ito alpha cube. Ito alpha to the 4th. Ito alpha to the 5th. Alpha to the 6th. Alpha to the 7. Alpha to the 8. Paikot-ikot pero papalayo ka ng papalayo from the origin. Paano naman sir pag negative exponents? Nako, kailangan mo pang mag-zoom in. Hindi na siya covered. Pero mangyari, yung susunod, yung alpha to the negative 1 nandito. Okay, nandito yan. Alpha to the negative 2 nandito. Yun naman papalapit ng papalapit sa origin. Hindi matatapos. Hindi matatapos. So what you see is what? What you see is actually a spiral. It's actually an infinite spiral of points. Infinite yan. Hindi ko lang ma-drawing yun nandun sa loob kasi nga masyado nang maliit to actually draw. Did you understand? Some elements, ano na-observe natin? In a group, some element will generate finite powers while some element will generate infinitely many integer powers. Anong meron sa I at anong meron sa square root of 2i? Bakit si I nag-generate ng finite pero si square root of 2i mag-generate ng infinite? No? In groups in general, nangyayari yun. At ang makakapagsabi nun ay yung order ng element. In fact, we have a theorem to summarize what's happening. Okay. Ito na. If an element A of a group is of infinite order, ano nang ibig sabihin natin ng infinite order? Pag sinabi ni Sir na infinite order, yung mga positive powers ni A, hindi bumabalik sa identity. Kahit anong gawin mo. Yung A squared, A cubed, A to the 4th, A to the 5th, hindi siya babalik ng identity. Okay? Ano sabi? Then two powers of A, two integer powers of A, will be equal if and only if the exponents are equal. Again, pag infinite power yung base, which is A, the powers are equal whenever the exponents are equal. And dahil if and only if to, pag hindi equal yung exponents, hindi equal yung mga powers. In short, pag nilista mo yung subgroup generated by A, dahil magkakaiba ng exponents tong mga to, itong mga to, hindi sila pare-pareho. They are not equal to one another. Each one is not equal to anyone in the set. Therefore, this set will be an infinite set. Okay? But, this is nicer. Kung sakaling yung element A ay may finite na order na n, halimbawa, kagaya ng I, pagdating ng I to the 4th, bumalik ka sa identity. Okay. Ang tanong, kailan nag-i-equal ang dalawang powers? Two powers will be equal precisely when their exponents are congruent modulo n. Naku, naaalala nyo ba to? Diniscuss ko ito dati when we're talking about equivalence relations. Right? Kaya kaya nga natin pinag-aralan ito. Okay? To prepare you for something like this. So, ang dalawang powers are equal if their exponents are congruent modulo n if the base is of finite order n. Ano ang ibig sabihin nito? For your information, this relation means that difference k minus l is divisible by n, or n divides the difference k minus l. So in other words, two powers can be equal even when they have different exponents. If the base is of finite order, halimbawa, tignan yung I. Alam niyo yung I to the 6, I to the 4 times I squared yan di ba? Ang I to the 4 mo nga kasi ay 1, kaya ang I to the 6 mo parehas lang sa I squared. Nakita niyo yung I to the 6 parehas sa I squared kahit na magkaiba yung exponents. Kasi yung 6 congruent yan sa 2 modulo 4. Kasi this time I has order 4. Meron lang 4 na points dyan sa picture kasi. Did you understand the theorem in this picture? Whereas yung number 1, theorem number 1 is the case of this one. Yung square root of 2i mo kasi ay may infinite na order. Never siyang babalik sa 1 pag pinataas mo yung exponents. Kaya the only way for two powers to be equal is for the exponents to be equal themselves. Did you understand that? Okay ba tayo doon? Pero kapag ang element ay may finite order 4, ang dalawang powers nag-equal if the exponents are congruent modulo 4. Okay. Okay, let's prove this. Then muna tayo sa number 1. Assume that A has an infinite order. So we will prove that two powers are equal precisely when their exponents are equal. First of all, notice that if A is of infinite order, the only way for a power of A to become the identity is when K is 0. Kasi nga, by definition, kapag sinabi natin A is of infinite order, pag ginawa mo yung A to the 1, A squared, A cubed, A to the 4, never babalik yan na identity. Yun yung meaning natin ng order, di ba? Na infinite. So the only way for A to the K to be the identity is when the exponent is precisely 0. Hence, if I have two powers and they are equal, group theory tayo, kunin mo yung inverse nung AL, A to the L, multiply mo on the right. Anong ginawa ko dito? Nag-algebra ko ha. Yung A to the L multiply ko on the right. Sorry, A to the L inverse pala. O, pag multiply ko yan, yung right hand side ko, maging identity yan. Kaya maging ganon. Diba? Tapos, laws of exponents will be applied on the left side of the equality. Maging A to the K minus L siya. Paano naging A to the K minus L? Yung A to the L to the negative 1 or inverse is A to the minus L. Tapos loss of exponent, add mo yung exponent. A to the K minus L. Okay? So in short, this power becomes the identity. So in short, in this case, kailan magiging identity? Only when the exponent is 0. And that means K is equal to L. Sandali lang ha. Okay. Let's continue. So anong ibig sabihin yan? O talaga namang magiging infinite set ito kasi magkaiba na exponent, magkaiba ng power. Ang mga exponent mo, mga integers. Ilang integers ba ang meron? Infinitely many. Kaya ilang powers meron ka? Infinitely many rin. But this type of infinity is just accountable infinity ha. Kasi ang nag-i-index ay si Z, which is a countable set. Ang exciting yung number 2 talaga. Let's say the element A has a finite order n. Ano nga definition natin ng finite na order n? Ibig sabihin, n is the smallest positive exponent so that a to the n is e. Meaning to say, si n yung pinakamaliit na exponent na positive na pwede so that a to the n is e. So in short, tuwing kailan ka nagiging identity, kailan nagiging identity yung power? Sige, tingnan natin ha. Halimbawa, example tayo. Ang order kunwari ni A ay 4. So pag nilista ko yung mga powers niya, a to the 1, a squared, a cubed, a to the 4th, a to the 5th, a to the 6th, a to the 7th, a to the 8th, etc. So ito, identity, a squared, a cubed, ang a to the 4th, e. So ang a to the 5th, babalik sa a. Ang a to the 6th, a squared, a cubed, ang a to the 8th, e ulit. Ang tanong dito, kailan bumabalik sa e? Tuwing kailan ka babalik sa e? Siyempre dahil ang cycle mo ay 4, parang you can imagine a circle na may 4 na points, no? E, A squared, A cubed. Tapos babalik ka sa E. A to the 4th, A to the 5th, A to the 6th. Ganyan siya. Ini-imagine. Naintindihan ninyo? Naintindihan ba ninyo yung sinasabi ni Sir? Do you understand my diagram? Kaya nga cyclic subgroups yung mga ito eh. Okay? So bumabalik ka sa E every time you get a multiple of 4. Naintindihan nyo? So in short, ang a to the k ay babalik sa e if k is a multiple of n. Or in another language, n divides the integer k. Or k is a multiple of n. You can also read it that way. Okay? So if you have two powers being equal, that means a to the, again, algebra tayo, yung ginawa ko kanina, maging a to the k minus l is e. So anong ibig sabihin yan? Dapat yung exponents are divisible sa n. O di ba yan ang meaning natin when we say k is congruent to L modulo n. So ang tanong natin, ano naman ang subgroup generated by A? It turns out that, ano bang sabi sa theorem? Hindi ko nabasa yata sa theorem. Let's recall the theorem. Ayun, hindi ko nga nabasa nga ito. Ano ba ang laman ng subgroup generated by A? Ang laman ng subgroup generated by A, kung si A ay may finite order n, is a set of order n. Anong sabi ng set of order n? May n elements lang din doon sa set. At ang mga nandito sa set na to ay E, A squared hanggang A to the n minus 1. Magkakaiba ito kaya there are n elements. Pero yung all other powers, mapuprove natin, it will just fall within this. Okay, that's what we're going to prove. So, nandito na tayo sa portion na to. We will prove that the subgroup generated by A is just these powers. Okay? How do we prove this? Well, technically speaking, itong set na ito ay subset talaga ito nung subgroup generated by A by default. Remember, ang laman nito yung lahat ng powers ng A. These are all powers of A, kaya talagang subset yan. Para mag-equal sila, ano na lang kailangang i-prove? For these two sets to be equal, kailangan mo na lang ma-prove yung pabalik na subset. Kaya nga tignan nyo yung start ng proof ko. Let X be in the subgroup generated by A. Dito ko kinuha si X. Ipapakita natin, pag kinuha mo si X dyan sa subgroup generated by A, makikita mo siya sa listahan na ito. Okay? That X will be something from here. How will that happen? Okay, tingnan natin. By definition, if X is in the subgroup generated by A, then X is some power of A. That's by definition of the subgroup generated by A. For some integer M in Z. Anong gagawin ni Sir ngayon? Ito yung gagawin ko. Alam mo si x ay a to the 84. Paano mo malalaman kung sino dito si a to the 84? Kung saan equal dyan si a to the 84? Kung ang n, for example, ay 10. No? Halimbawa, hindi, wag ng 84. Grabe naman yun. Ano ba yung example ko kanina? Bibigyan ko kayo ng example ha. Ang n ko ay 4. So, ang subgroup generated by A according to the theorem, 4 lang ang laman. Ito lang, enough na yan. They will form a circle like this. A squared, A cubed. Ito yung A to the 4th. Ito yung A to the 5th. A to the 6th. Ano ba tinanong ko kayo? Tinanong kayo ni sir. Ano yung A to the 73? Saan dito equal yung A to the 73? If you keep on doing this in your circle, no, saan magpo-fall yung A to the 73? How will you know? Sige nga, saan equal yung A to the 73? Sa E, sa A squared, o sa A cube? Sorry. Remember, in this case, ang A to the K is equal to A to the L if and only if K is congruent to L modulo 4. O sige. Alin dito sa apat na to equal si A to the 73? Saan siya equal? Dito ba? Dito, dito, dito. Okay, may mga sumagot. Sabi nila kay A daw. Bakit kay A? Anong naging basis ninyo? Kasi si 73 is congruent to 1 modulo 4. It's not congruent to 0 kasi hindi siya divisible sa 4. It's not congruent to 2. Paano ba nalalaman kung saan siya mag-fall? Ano yung ginagawa nyo sa isip nyo when you think about this? Meron kayong ginagawa eh. Can you share that to me? Anong operation yung ginagawa nyo to determine saan mag-fall yung A to the 73? Ayan, very good. Nagdi-divide kayo, kinukuha nyo yung remainder. Diba? You actually divide 73 by 4. Naku, hindi na ako marunong nito. Paano nga ito? Paano nga ito? Saan ba inuuna? Shit. Ganyan ba yun? Ay, mali. 1 lang, tapos 4. Shit. Ay. Subtract ba? Subtract. Okay. 3, 3. 18. 32. Remainder 1. Okay. Remainder 1. Kaya 73 is congruent to 1 modulo 4. Kaya I know that A to the 73 is A to the 1. Or A. This is the same thing that you are doing if let's say, sinabi, halimbawa, kunwari, ngayon, today is, for example, today is Wednesday. Tinatanong kayo, what day is it? So, 90 days from now. Ano ba ganyan yung tanong? Today is Wednesday. What day is it 90 days from now? How would you answer this? You are basically talking about what? Modulo 7 arithmetic. Na? So, meron kang Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, naku, kulang space, and Saturday. So, segue tayo ha, kasi I want you to follow the proof, hindi lang basta may proof tayo. 0, 1, 2, 3. Iko-code ko siya as like this, parang Z sub 7. Okay? So, we are now at 3. When you say 90 days from now, so you add 90 to 3, So I get 93. So I'm going to divide that by 7. 1, 7, 23. Ganyan ba yun? Tama ba si sir? So, is that a Tuesday? Tama ba si sir? Ganyan ba?
Yes po.
Yeah, that's a Tuesday. Alam nyo, kailan ko lang nalaman, or hindi ko alam kung alam nyo, yung ano pala, yung word na Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Ang etymology pala na to ay yung 7 heavenly bodies na nakikita natin sa langit. Na? For example, obviously this is the sun. Monday is actually the moon. Tuesday is Mars. Wednesday is Mercury. Thursday is Jupiter. Friday is Venus. Is this a Venus? Yeah. Saturday is what is a this is Saturn. So Saturday is Saturn day. Sunday is Sunday. Monday is actually Moon day. Ang tanong bakit yung Tuesday Mars? Kasi ang origin naman talaga ng mga itong ginagamit natin sa English, English 'yan. Pero pag titingnan mo yung origin nito, yung which is the Latin one, ano ba, wag na yung Latin, yung Spanish na lang. 'Di ba ang Tuesday, Martes, Mars. Okay? Kunti ka na maging Marites. Ang Wednesday ay Miyerkules, Mercury. 'Di ba? Miyerkules. Jueves is for Jupiter. I don't know if the spelling is like this or each. I forgot kung ano yung Spanish. Yung Venus is Viernes. O yung Saturday, yung Saturn. Ano ba yung sa Sabado? Ganyan ba? Pero sa Spanish, ang Sunday, hindi linggo eh, no? Filipino yung linggo, but yeah, in Spanish, it's Domingo. Sa mga nagbibisaya or ano, Cebuano, I think they are still using Domingo, if I'm not mistaken. Tama ba kayo mga marunong mag-Cebuano dito? Is Sunday, Domingo still? Oh, di ba? Kapag Sunday, Domingo. Tapos itong Monday, Lunes, kasi galing yan sa Luna. Di ba? Luna. Kailan ko lang nabasa ito. I am just sharing kasi I'm happy to find out na yun pala yung origin nun. No, ano yung pito na yan? Yan, kasi naunang panahon kasi, yung pito na yan ang ang paikot-ikot every 7 days. Ano sa night, di ba mahilig sila mag-observe sa night sky before because they wanted to tell kung anong oras na. No? Gusto nila gumawa ng system of time para makapag-navigate or etc. Ang in-observe nila yung mga planetary motions or yung mga motion ng mga between gano'n sa langit. Hanggang napansin nila yung pitong pinakamaliwanag na objects na nakikita sa night sky. Ito yung pito na yun. And with reference to the 7, doon nila pinangalan yung 7 days of the week. Yeah, correct. Nanggaling siya sa mga Roman gods. Of course, yung religion ng mga tao nung sinaunang panahon na yun. But yeah, yung pitong nakikita nila sa langit na yun, dahil nga malaki at maliwanag, pinangalan nila sa name ng mga gods or whatever. Tapos, yun, dun from there, nag-originate yung pangalan ng 7 days of the week. And then, kasi I happen to pause na muna natin yung chikahan muna tayo. Total, nakakakalahati na tayo. Ayan, pasensya na. Buti pinaalala sa akin ni Mercy. Ano ba tatawag sa'yo? Divine o Mercy? Or Divine Mercy? Ano bang tinatawag sa'yo ng classmates mo? O anyway, salamat sa iyo. Ayan. Ayan yung proof. Ulitin ba natin? Hindi na record kasi, no? So, malas ka kapag hindi ka umaten ngayong araw. But yeah, this is basically the proof. We simply apply the division algorithm on M, dividing it on N, we get the Q and the R. Tapos, we express using the fact that N is the order of A, you get an E. So, basically, X is just A to the R. And because R is a remainder, it should be something from 0 to N minus 1. And therefore, X belongs here. So, pag ang X mo nandito rin yung X. Kaya, yeah. So, basically, that's it. So, the subgroup generated by A will have N elements only. Namely, E, A squared up to the A to the N minus 1. So, meron tayong natutunan ngayon. Ang natutunan natin is that the order of the element is basically equal to the number of elements this subgroup has. Kasi kapag sa A ay infinite ang order, infinite yung set na ito. Kapag naman si A ay may finite order na n, nakita nyo naman ilan ang laman nito. Ano? And then, si a to the 0 hanggang a to the n minus 1, pag binilang nyo yung lahat, that's all in all n. And in particular, if A has a finite order n, then ang nth power ng A is equal to A to the R, where R is the one that's left when you divide n by mali ito. When n is divided by mali ito. A to the n is A to the R, where R is the remainder when m is divided by n. So kindly correct that. Medyo alam ko nung tinatype ko to, umiinom ako eh. Kaya, yeah. Nagkapalit-palit. Okay? So I think we are now on the last slide for this lesson para magpatuloy na sa next lesson. Yeah. So here is an exercise, but I'm trying to do it now. So here S is the set of real numbers excluding 0 and 1. No? I exclude 0 and 1 para yung numerator at denominator hindi nag-0. Okay? Any one of the numerator and denominator of F will not be 0. With that, pag kinonsider nitong F na to, it's a bijection from S to S. Okay? Anyway, basta bijection yan at ito yung function. Ang operation natin ay composition of functions. Okay? So sabi, calculate f to the 200 of 2. Ang isipin ng f to the 200, i-compose mo si f sa sarili niya ng 200 times. Kukunin mo yung composition ni f ng 200 times. So halimbawa, sino si f squared of x? Sino ba si f squared of x? Ang isipin ng f squared of x, in this context, that's f of x. Di ba? Ano ba yung f of x? That's basically f of x minus 1 over x. And if you apply f on this once again, you get this whole thing minus 1 divided by that whole thing. And when you simplify, you can multiply an x on both of these. Ang may iwanan ay, anong nangyari? Tumalon. Wait lang. Ang may iwanan ay x minus 1 minus x all over x minus 1. One over 1 minus x. Is that correct? Kung negative 1, ilagay ko na sa denominator para mawala yung negative. Ayoko nakakita ng negative sa unahan. Okay? So that's f squared of x. How about f cubed of x? F cubed of x is f squared of f of x. In short, yeah. Tama ba si sir? F squared of f of x. So, ito na yung f squared eh. Di ba? So, parang i-apply mo yung f squared doon sa x minus 1 over x. Yung f squared of x is in the previous computation. So, that's 1 over 1 minus x minus 1 over x. Okay? And then we find that we can multiply again by x over x. Ang mangyayari, x over x minus 1. Oh my gosh. Okay, x. X na lang, no? This actually surprises me. And why do you think this is a special occasion na naging X yung sagot? Ano ba yung X? Di ba siya yung ID? Di ba? Siya yung image ng X under the identity function. Did you remember this? Identity function? Okay. So that means to say, ng F cube is equal to the identity already. So in terms of group theory, F is a function that has an order 3. Order 3 function siya kasi after applying F 3 times, naging identity ka na. So therefore, what is F to the 200? If F has order 3. Sabi natin, you can divide 200 by 3. Get 6, 18, 20, 6, 18, remainder 2. So therefore, f to the 200 is equal to f squared. Tama ba? So therefore, f to the 200 of 2 is equal to f squared of 2. But we have an f squared of x. F squared of x is 1 over, tama ba to? Yeah. 1 over 1 minus x. Kaya ito yung 1 over 1 minus 2. So the answer is 1 over negative 1 or negative 1. So the final answer is negative 1. Naintindihan niyo yung example? So the final answer is negative 1. Okay, so without further mentioning many things, no, we will continue to the next lesson because the next lesson is just an extension of the previous lesson. Alam nyo, di ba kanina, sometimes there are cases when your group may be generated by a single element, and that is, well, an occasion that doesn't happen all the time. For example, yung S sub 3 can be generated by a single element, but Z sub 6 can be generated by 1 or by 5. Nakita nyo naman yan. In group theory, whenever a group may be generated by a single element, that's very nice. Why is that very nice? Kasi basically, ang elements ng group mo ay powers lang ng isang element. Pag alam mo yung isang element na yun, alam mo na lahat ng element ng group. Did you understand the idea why this is so important in the analysis? Yeah. So, balikan lang natin ito. Ito yung recall. Ito yung main result natin last time. If you take the subgroup generated by A, it's just a set of integer powers. If A has an infinite order, this is infinite. But if A has an order n, which is finite, this has n elements. Excuse me, namely A squared up to A to the n minus 1. All right, so in this lesson, we will call a group G a cyclic group if it can be generated by a single element. Kung kayang ma-generate yung buong group mo by a single element only, no, the group is said to be cyclic. Ang tawag natin sa such an element A that generates the group is of course, it's called a generator. Hindi naman pinag-isipan masyado yung pangalan, no? Okay? So as we can tell, if G is a finite group of order n, then G is cyclic precisely when G has an element of order n. Kasi yung element of order n na yun, siya yung mag-generate doon sa buong group. Kasi nga si G ay may n elements. So halimbawa, you know, the additive group of integers is cyclic kasi it can be generated by which elements once again. Kanina tinignan natin ito, sino nag-generate kay Z? Can you tell me what are the generators for Z?
1 and -1.
Yeah, based on a previous example, we noticed from there that the generators are 1 and -1. Correct. The group Z sub 6 is cyclic, no? And we found out in the previous calculation that the generators are, what are the generators for Z sub 6? Hanapin natin yung example na yun. Let me go back to that slide, ha? Dali. Where we talk about Z sub 6. I think it's malayo-layo na pala yun. Nasaan na yun? Oh, hindi yan. Malapit na dito. Ayun! Yan. So, naalala nyo to, it can be generated by 1 and 5. So, we can say that the generators for Z sub 6 are 1 and 5. Correct kayo dyan. You know, in general, Z sub n will always be cyclic for n greater than 1. Okay? Because, hindi mo kailangan ma-identify lahat ng generators. All you need to do is to find the generator. Kasi yun lang naman ang kailangan sa definition. A group is cyclic precisely when it has a generator. And Z sub n is can be generated by the element 1 all the time. It can be generated by the element 1. Modulo n tayo kasi if you keep on adding 1 to itself, mag-generate mo lahat ng Z sub n. But I want you to look at the next example, the Klein-4 group whose table is given as shown. Again, the Klein-4 group ang ating standard model. Meron kang rectangle dito na hindi square. Ang E ay yung identity. Yung A, yung mirror reflection na ito. Yung B, yung mirror reflection na ito. At yung C, siya yung rotation na 180 degrees. Yung E, of course, yung identity. And these symmetries form a group table called as the Klein-4 group. Ang characteristic ng Klein-4 group, lahat sila self-inverse. Makikita nyo in the main diagonal, all identities are there. So meaning to say, every element has a square equal to E. So A, B, and C has order 2. Tingnan nyo, no? Anong order ni E? Siyempre 1 kasi identity siya. Ang order ni A, ang order ni B, at ang order ni C, pare-parehas 2. Kasi they, what? Their squares are all equal to E. Okay? Meron bang element ang nakaabot ng order 4? Siyempre, wala, obviously. So, kung ganon, si Klein-4 ba ay cyclic or hindi? Is Klein-4 cyclic or not? Meron ba makakapag-generate kay Klein-4 na isang element? None. Kasi, for example, ilan ang mag-generate ni A? 2. Remember, kung ano yung order, yun yung number of elements na mag-generate niya. So, B can generate only 2 elements. C can generate only 2 elements. Yun yung sabihin ng order talaga by the previous theorem. So therefore, none of the elements has order 4, so none can generate the entire group. So what is the Klein for group? It is not cyclic. Okay? Kanina ko pa alam na yung S sub 3, naalala niyo yung S sub 3, yung mga rho, tsaka yung mga mu. Kanina ko pa alam actually na hindi yun magiging cyclic group. None of the elements can generate the entire group kasi ang S sub 3 ay hindi abelian. And as your teacher, alam ko yung theorem na ito. The theorem states that if your group is cyclic, automatic abelian siya. So in other words, kapag ang group mo ay non-abelian, kiss ka agad, hindi na yun cyclic. Did you understand that? Pag ang group mo non-abelian, hindi na yun cyclic. Kasi ang totoo, lahat ng cyclic group ay abelian. So, what is the proof? So, I don't think I have a proof here in the slide. So, let me write the proof for you. So, let G be a cyclic group. Anong ibig sabihin ng cyclic group? Anong ibig sabihin ng cyclic group again? Anong ibig sabihin ng cyclic group? Anyone? Very good. It can be generated by one element. So, in mathematics, how do we state that? Sabihin nun, you can find one element of G that can generate all of G. So, in symbols, there exists an element little g from capital G such that capital G is itself the group generated by G. In other words, all the elements of G are just integer powers of little g. Now, we will prove, what do we need to prove here? We will prove that G is abelian, okay? And to prove this, anong kailangan gawin? Kukuha ka ng dalawang elements. So, let's take two elements, let's say x and y from G. Since G is generated by little g, meaning to say, lahat ng elements ng G are just powers of little g. And that includes x and y. So in other words, I can write x as g to the, let's say, r, and y as g to the s, where I would like to write here r and s are some integers. Naintindihan ninyo bakit ito nangyari? Kasi nga, sa x and y, elements ng G. Eh si G pala, gina-generate lang ng little g. So in short, si x and y are just integer powers of G. So let's say, sabihin na lang natin si x ay G to the r, si y ay G to the s. Kung saan si r at si s, mga integers. Anong mangyayari ngayon? Ito na yung mangyayari. If you multiply x times y, you will get G to the r times G to the s. But by the laws of exponents, this is G raised to r plus s. Ano ba yung r and s? R and s are integers. So, ang r plus s parehas lang sa s plus r because they are just integers and we are just adding them. Again, by laws of exponents, this is G to the s times G to the r. Now, this time, this is y, and G to the r is x. Therefore, as a conclusion, G is abelian, and we are done with the proof. No? Kung mapapansin nyo, ano yung pinaka-crucial na part ng proof? Sino yung actually nag-proof? Sino yung nag-giveaway para masabi natin na lahat ng cyclic group abelian? Sino yung nagsarado ng proof? Aling part ng proof yung pinaka-importante dito? Ba't naging abelian talaga? Now, when you try to read a proof, you don't just read it and try to understand line per line. Sometimes you have to analyze it carefully. Alin dito yung part na nasabi na-convince ka na, yeah, tama nga yung proof niya, or yeah, tama yung conclusion that the group is abelian whenever it is cyclic. So which part was it? Sige nga, can you analyze the proof? Tignan nyo sino yung nagbigay ng daan para masabi natin na lahat ng cyclic groups ay abelian. Yeah, yung laws of exponents. Yeah? Pero maliban sa laws of exponents, ang talagang critical na part dyan, alam nyo kung ano? Ito, sasabihin ko na, ito. Yung fact na ang R plus S ay pareha sa S plus R. Kasi yan ang nagbigay ng tulay para mag-equal yung XY sa YS. Kaya nga, this is all thanks to the integers. Si R at S kasi ay mga integers, and we know that integers when added, they commute. Ang addition of integers kasi ay commutative. Kaya salamat sa mga integers, ang mga cyclic groups, lahat ay abelian. Naintindihan niya, yun yung pinaka-critical na fact dyan eh. Kaya kapag ang integers mo hindi nagko-commute under addition, problema ito. This will not be a theorem. Nakita niyo, ito yung fact na very critical dyan. Siya ang nagbigay ng daan para maging abelian lahat ng cyclic groups. Ayan. Siyempre, ang susunod na tanong ko dyan, lahat ba ng abelian group cyclic? Hindi. Can you give me an example of an abelian group that is not cyclic? Can you give me an example of an abelian group that is not cyclic? Anyone? Abelian that is not cyclic.
Yung V4 po ata.
Yes, very good. V4 is abelian. The line 4 group is abelian, but not cyclic precisely. So there are abelian groups which are not cyclic. So kung titignan niyo yung diagram, Venn diagram natin ng mga groups, so let's say this is the groups, the set of all groups. Kalahati niyan, huwag natin sabihin kalahati. Basta mahati mo siya into two categories, no? Ito yung abelian, ito yung mga non-abelian. Among the non-abelian, among the abelian ones, ito yung mga cyclic. Okay? So we are in this lesson, we are studying this portion of the diagram. And hopefully, at the end of the semester, mapag-aralan natin lahat. So nakikita niyo na yung map kung nasaan na tayo, na? So, although may examples tayo ng mga abelian na hindi cyclic, nandito yung Klein 4. For example, nandito yung Z, nandito yung Z sub N, no? Sa mga non-abelians, nandito yung S sub 3, marami pa. Right? Naiintindihan ninyo yung ating map kung nasaan na tayo at ano na yung pinag-aaralan natin? Aaralin natin yan part by part, yung ating group theory. Para hindi kayo naliligaw, alam nyo kung ano yung pinag-uusapan. Matututunan natin later. Kapag ang group ay hindi cyclic, pero abelian siya, abelian na hindi cyclic, kagaya ng Klein 4, lahat ng groups na ito ay actually binubuo lang ng mga cyclic groups. Ano yung sabihin ng binubuo lang ng mga cyclic groups? Halimbawa, alam niyo yung Klein 4 na yan, hindi man siya cyclic, pero isomorphic siya sa Z2 direct product Z2. Alam niyo yung Z2 direct product Z2, ito yung 0, 0, 1, 0, 0, 1, 1, 1. Pag makikita nyo, ginawa nyo yung table nito parang Klein for group. Matututunan natin later yan. Basta ang group mo ay abelian, actually, binubuo siya ng mga cyclic groups. Ibig sabihin ng binubuo, parang may mga component siya na cyclic groups. Pero paano natin mapapatunayan yun? It's a very, very, very long story. So, let's wait for the right time to discuss that. Okay. May tanong si Sir. Si ZA plus ay cyclic, di ba? Correct. How about Q plus? Ano yung Q plus? This is the set of all rational numbers under addition. Is this group cyclic? Meron bang isang rational number na kapag pinaulit-ulit mong i-add sa sarili niya, tapos kunin mo yung mga inverses, lalabas lahat ng rational number? Is that possible? Kasi possible yun sa Z. For example, si 1 will generate all of Z. Kapag inad mo ng inad si 1, tapos kinuha mo yung mga inverses nila, lalabas lahat ng Z. Yung all of Z. Ang tanong, meron bang ganong element sa Q? What do you think is the answer to this question? Any kind of guess is welcome. Anong hula ninyo? Anong pakiramdam ninyo? Sometimes kasi sa math, hindi naman laging puro talino eh. No? Minsan, nakakatulong yung pangdama. No? Although hindi natin gagamitin yung pangdama to justify things, but sometimes these intuitions can help us go to the right direction. No? Anong nararamdaman nyo about this? Is this really cyclic? Meron bang rational number na kayang i-generate lahat using addition? None? Sabi ni Anthony na from Bulacan. Ano ba yung Bulacan? Apelido mo ba yan, Anthony? Okay. Kala ko Anthony from Bulacan. Kala ko proud ka lang. From Bulacan, Philippines. Kala ko ganon. Apelido mo yung Bulacan. Okay. Sabi rin ni Mercy, na hindi ko alam kung divine o mercy. Mercy, anong gusto mong tawag sa'yo? Divine o mercy? Divine mercy. Okay, sige. Divine mercy. Gusto mo yung dalawa. Divine mercy. Sabi niya, hindi raw cyclic ito. Yes, actually the answer is no. Ngayon, dito napapasok yung pagiging potential na mathematician mo. Paano ko ipoprove na hindi ito cyclic? Kasi to prove that this group is not cyclic is to prove that it has no generator. Narinig niyo yung ipoprove ninyo? It has no generator. Kapag ganun yung ipoprove, paano nag-proceed usually? Tinuruan ko kayo niyan, di ba? If you're proving something that does not exist, no, or is not, no, has no, how do we approach it normally? How do we start the proof? Very good si Kat. Very good si Claire. Kunwari, cyclic siya. So we will prove it by contradiction. No, so let's start. Wala yatang proof ito dito sa slide ko. So let's suppose that Q plus is cyclic. Q plus is cyclic. Kapag cyclic siya, by definition, ayun yung sabi, may generator. Then there is a fraction, a rational number R that generates everything. Q is the subgroup generated by R. So, remember, we want to be able to get a contradiction. No? Saan tayo hahanap ng contradiction? Saan kamay ng Diyos natin kukunin yung contradiction na yan? So, ganito. Dahil si R ay rational number, alam natin ang itsura niya. Na? Tama? So, ano itsura ng isang rational number? Normally, it's a fraction of two integers. So, we can write R as M over N, where, ito yung mga conditions ko about M and N. Una, gusto ko si M, of course, si M ay integer. So, si N ay hindi dapat 0. So, peppersahin kong si N to be a positive integer. So, halimbawa kung meron man akong 3 over negative 2, ilagay mo na lang yung negative sa itaas. Parang m ko negative 3, ang n ko ay 2. Okay? Laging i-fix na lang natin na positive yung denominator. Naintindihan niyo ba itong restriction na ito? Naintindihan niyo ba ba't nire-restrict ko yung denominator to be positive para iwas maging 0? Anyway, kung magne-negative man siya, you can just place the negative on the numerator. Let m suffer the consequence. No? Parang ganun yung idea. And at the same time, I want m and n to be selected. Kasi remember, halimbawa, ang 2/3, parehas sa 4 over 6. Right? This could be r. Ang tanong, kapag 2/3 ay equal sa 4 over 6, anong value ng m at n? Nakakalito. Pwedeng ang m mo 2 at ang n ay 3, or pwedeng ang m mo ay 4 at ang n mo 6. Hindi pwede yun. Hindi sila uniquely identified. So, ang gagawin natin, i-cross out natin ito. We will always select the one that is in simplest form para unique yung value ng m at n. Did you understand? Yung condition na yun may impose nyo in abstract algebra to say that 2/3 is in simplest form or m over n is in simplest form, you always would write this condition. Kailangan yung m and n may GCD na 1, or in other words, they are relatively prime. So number theory, yan yung tawag sa kanila. They are not necessarily prime, but they are relatively prime. Okay? Kasi they will not divide one another. Kaya yung fraction na m over n will be in simplest form. Okay ba tayo dito? So far? So far? Okay. Okay. Ganito, bibigyan ko kayo ng idea kung how to proceed in the proof, okay? Halimbawa yung generator na pinopropose ko, kunwari 1/2. So, ang m ko ay 1, ang n ay 2. In order to prove that 1/2 is not a generator actually, ano kailangan mong gawin? Kailangan natin makapag-produce ng isang fraction or isang rational number na hindi multiple ng 1/2. Kasi diba, repeated addition means multiple. So, kailangan natin mag-produce ng isang fraction na hindi, multiple ng 1/2. Sige nga, can you give me one? Kunwari, ang R ay 1/2. Ayan, halimbawa, sabi ni Claire, 1/3, no? Take, for example, Q to be 1/3. Itong 1/3 na to will never be an integer multiple of 1/2. Kahit anong gawin mo sa 1/2, i-add mo ng i-add sarili niya, kunin mo yung negative, hindi lalabas yung 1/3. Ubusin mo man buong buhay mo. No, that's the idea. So going back, I want you to consider the rational number 1 over n plus 1. Kagaya ng pinapropose ni Claire. Alam mo kanina 1/2 yung R ko. Ang pinapose niya 1/3. Sabi niya yung 1/3 sir, hindi yan magiging multiple. So ito yung ating gagamitin sa pagkakaroon ng contradiction. Paano natin magagamit ito? Since Q is generated by R, in particular, yung 1 over n plus 1 ko is an integer multiple of m over n. So, ibig sabihin, there exists an integer k such that yung 1 over n plus 1 mo na yan ay k times m over n. Did you understand this part so far? Naunawaan niyo to? Okay. So, rearranging this equation will give us n over n plus 1. Anong ginawa ni sir? Nag-multiply ako ng n on both sides. At may iwanan sa kanan k times m. The right-hand side is a product of the integer k and the integer m. So, their product is again an integer. So, ano nangyari? Aha! Yung n over n plus 1 ay isang integer. So, that will mean that n plus 1 divides n, which is a contradiction. Pero pwede bang yung n plus 1 dinidivide si N? Hindi. Kasi si N ay positive integer. Pag positive si N, hindi pa pwedeng maging divisible si N sa susunod sa kanya. Kalokohan yun, no? Naintindihan niyo bakit may contradiction? Ang nangyayari, yung N, i-divide yung susunod sa kanya. Parang ang nangyayari, si 2 magiging divisible sa 3. Si 3 magiging divisible sa 4. Parang ganun yung nangyayari. Si 4 magiging divisible sa 5. That's a contradiction. So what we suppose cannot be true. Ano ba yung sinupose mo? O yun. So that cannot be true. Therefore, Q plus is not cyclic. Anong natutunan natin sa example na ito? Tingnan natin. Ito si C plus. Ito si Q plus. Okay. Ito yung mga classifications. Are they groups? Okay, yun yung tanong. Are they abelian? Okay. Parehas infinite. So, countable ba parehas? Cyclic? Okay. Kung lalagyan natin ng checklist, these two are groups. These two are abelian. In fact, these two are countable. But one is cyclic, the other is not. So what does this show? This shows that Q plus as a group is not isomorphic to Z plus as a group. Although they are both abelian and countable as groups, but because one is cyclic, the other is not, hindi pa pwedeng sila ay isomorphic. Kaya as groups, one is not isomorphic to the other. Naintindihan niyo ba yung sinasabi ni Sir? Bakit hindi sila isomorphic? Kasi isa cyclic, isa ay hindi. Okay tayo? Can I proceed? Alam nyo, kapag si Sir ay nag-discuss, I don't just put random examples. Hindi ako yung tipo ng teacher na mag-example. O sige, compute nyo ito. I don't really just give examples. Pinag-iisipan ko yung mabuti, yung mga example na binibigay ko. Because in examples, I want you to learn something more. Meron tayong dapat natututunang bago whenever we have examples. May sinasabi, no? May reason why these examples are presented. And sana, every time na may example ako, iniisip niyo yun, ano kaya yung mensaheng gustong ipaparating ni Sir dito? Kasi alam nyo, minsan doon ako kumukuha ng mga itatanong kapag nasa exam. Sa mga example na yun, yung mga insights. Minsan doon ako kumukuha or humuhugot ng mga tanong. Okay. It turns out na hindi naman pala marami ang mga cyclic groups. No? Paano hindi marami ang cyclic groups, sir? Tingnan natin. Sabi ng theorem na ito. Pag si G ay cyclic, and it's, of course, may generator, di ba? Let's say a generator is A, there are only two cases. No? Si G ay generated by A, cyclic, okay? Yan ang definition. Dalawa ang cases. Pag si A ay may infinite na order, at pag si A ay may order na n, tapos finite. Okay, yun yung other two cases. Pag pala yung generator mo ay may infinite na order, anong conclusion? G is isomorphic to Z. Kapag naman si si generator A ay may order na n, ang conclusion, si G isomorphic lang sa Z sub n. Ang tanong, bakit? No, bakit? Why is this true? Kasi, gagamitin natin yung theorem natin kanina. Kasi kapag si G ay infinite, si A ay may infinite na order, it's generated by A, sabi ng previous theorem, ang laman nito, itong set of powers na to ay infinite at walang dalawa dyan ang parehas. No? Ang tanong, bakit isomorphic yan sa Z, sir? Ito yung isomorphism. I will show you the isomorphism. If this is the set Z, okay? Ay, sorry. 0, 1, negative 1, 2, negative 2, and so on. Where's the isomorphism? The isomorphism is this. Okay? Yung isomorphism natin is the function that what? That takes a power a to the n to n. Papadala mo yung a to the n or i-associate mo lang siya dun sa exponent. It will be an isomorphism. This is clearly bijective. Do you see that it is bijective? Why is this operation preserving? Kasi pag meron kang dalawang powers ng a, loss of exponent, that's a to the n plus m. Basically, by definition, that's n plus m. And n is phi of a to the n. And m is phi of a to the m. That's why phi is operation preserving aside from the fact that it is a bijection. So, isomorphic ka lang sa Z. E paano naman kapag sir si A ay may finite order na n? Sabi ng previous theorem ulit kanina, in this case, yung subgroup na ma-generate ng A, n lang ang laman. Hanggang a to the n minus 1. No? At ito yung isomorphic sa z sub n because of the fact na ang z sub n kasi laman 0, 1, 2, 3, n minus 1. Where is the isomorphism? The isomorphism is done in this manner. Kagaya nung sa infinite na case. Tinatapyas mo yung a, iniiwanan mo lang yung exponent. Why is this operation preserving? Eh di ba kapag nagmo-multiply ka, let's say a, ano ba, ang n natin kunwari, 4. Multiply mo a cubed times a squared. O di maglo-law of exponent ka, a to the 5. Pero dahil ang 5 ay congruent to 1 modulo 4, that's just a. Pag in-applyan mo ng isomorphism yan, ito yung nagiging 3, ito yung nagiging 2. Ina-add mo siya modulo 5, the answer is 1. Diba? Nakita nyo why this is an isomorphism. Okay. So lahat pala ng cyclic groups na order n, isomorphic lang sa z sub n. At lahat ng cyclic group na infinite, automatic sa isomorphic sa z. So therefore, this theorem is so important because it classifies every type of cyclic group. Kaya nga sa lahat doon sa map natin ng groups, if you can remember the map that I have drawn, the easiest to study are the cyclic groups kasi they are very well understood. No? Naalala niyo yung map ko na yon? Nasaan ba yung map na yon? Idodrawin ko na lang ulit, hindi ko na makita. Ito yung map of groups. Ito yung mga abelian, non-abelian, a tiny portion of the abelian side, no, are the cyclic ones. So we can safely say that we fairly understood everything that's happening within the shaded region. Kasi dalawa lang pala ang groups dito. Actually, infinitely many. Kung hindi Z sub n. Kung makakita ka man ng ibang cyclic groups, isomorphic lang sa isa dyan sa dalawa. Na or for some value of n. Did you understand me? Did you understand? Ang tanong, tatanungin nyo si Sir. Do we understand the entire map, sir? Or lahat ba na-classify na natin lahat ng groups all in all? The answer is no. This is why group theory is still an active area of research in mathematics. When you say it's an active area, many of the questions are not yet answered. No, maraming groups pa ang hindi well understood. ano yung sabi ng hindi well understood, wala pa tayong classification, especially dun sa mga infinite na non-abelians. Halimbawa, hahatiin mo to sa infinite, finite. Yung mga finite non-abelian group, somehow meron tayong mga pamamaraan to classify them, but pag infinite tas non-abelian, this is kind of hard to study. Okay? Kaya nga ang group theory is still an active area of research in mathematics because the classification problem is still not fully solved. Marami pang dapat alamin sa group theory. Nakuha niyo ang pure mathematics, ano ginagawa sa pure math, no? It's basically classification of things. When are two things the same? When are two things not the same? When are two things related? Kaya nga sabi nila, pure mathematics is basically the study of relations between things. We are studying two things that may seem unrelated at first, but in the end, you will find out that they are actually related. Kaya nga as a corollary of a given order, there is a unique cyclic group. I'm not saying there's a unique cyclic group kasi marami, palitan mo lang yung pangalan ng mga elements, you will form another group, di ba? But we say up to isomorphism. When you hear the word up to isomorphism, ang bilang natin sa dalawang groups na isomorphic lang naman, we count them as one. Hindi natin sila binibilang na magkaiba. Halimbawa, nakakita ka ng, alam yung IREL na group natin, yung attention, right face, about face, left face, we found out that this is isomorphic to Z sub 4. Ang generators nito R o kaya L. No? Ito yung generators niyan, R at L. Kasi pag nag-right turn ka na ng right turn, iikutan mo lahat ng directions. O kaya pag mag-left turn ka na mag-left turn, iikutan mo lahat ng positions. Hindi ba? Kaya si R at L ay mga generators. So we know that G is a cyclic group. Because this is a cyclic group of order 4, automatic isomorphic siya sa Z sub 4. Let us say, nakakuha ka ulit ng another group of order, cyclic group of order 4. Isomorphic ulit yun sa Z sub 4. And because being isomorphic is an equivalence relation, that means to say that any two cyclic groups of order 4 must be isomorphic. Kaya nga, there is a unique cyclic group up to isomorphism. I'm not saying there is a unique cyclic group per se. No? I'm saying there is a unique cyclic group up to isomorphism. We're not counting two groups as two kung isomorphic lang naman sila. We're counting them as one. Yun yung ibig sabihin. Naintindihan ninyo? Okay. Akala nyo na intindihan na natin yung cyclic groups ng maluwalhati, lahat nasagot na natin, not yet. Kasi for example, what can you say about the subgroups of cyclic groups? Na? Kaya ba nating ilista lahat ng subgroups nila? Kasi a subgroup analysis is one of the aspects of this subject. Meron kang group, you wanted to know how the subgroups behave, what are all the subgroups, so I can draw the family tree. Do you remember the family tree of subgroups? Na? Those are some aspects that we still need to consider. Kaya nga, ang next na question natin, what can we say about the subgroups of a cyclic group? It turns out that the answer is so nice. What do you guess? What is your guess? It turns out that for a cyclic group, lahat ng subgroups mo ay yung mga cyclic subgroups lang. Ha? In short, ang subgroups ng cyclic groups, cyclic din. Na ipamamana ng mga cyclic groups ang pagiging cyclic sa kanilang mga anak. Did you understand me? Naintindihan niyo yan? So in other words, kapag ako'y may group of order, let's say, Z sub 6, alam natin cyclic yan. Ilan ang elements nito? 0, 1, 2, 3, 4, 5, 6. Kunin mo lang pala itong 6 na to. Itong 6 na to. Pag nalista mo yung anim na yan, sure ka na wala, yan ang lahat ng mga subgroups, wala ng iba. Kaya kapag cyclic groups, medyo madaling maglista ng mga subgroups. You just need to find all of the cyclic subgroups. You know how easy these are to generate, right? Kaya kapag cyclic ang group, it's kind of, it's the nicest type of groups. Kaya pinag-aaralan to sa umpisa. Sila yung mga unang-unang groups na may encounter ninyo. Kasi they are the ones which have a very simple structure. Na una, ang cyclic groups, isa lang yan of a given order. Kung order 5, Z sub 5. Kung order 11, Z sub 11. Pag infinite, Z. Wala nang iba. Ganun lang kasimple. Furthermore, pag ang group mo na nalaman mo, narinig mo, cyclic siya, paano mo malalaman yung mga subgroups? Napakadaling ilista. Ilista mo lang yung mga cyclic subgroups, tapos na. Naiintindihan nyo? Okay. So this is the theorem. The theorem is simply stated, but yeah, if you don't think of it carefully, it might mislead you. Ang sabi nito, subgroups of cyclic groups are cyclic. Meaning to say, the subgroups themselves can be generated by one element only. Did you understand? Naintindihan nyo ba? Okay. Yung proof nito, akala nyo madali, no? Kasi most of the time, mga proofs natin medyo madali pa. But this time, I think this is the first theorem in group theory where you will find the intricacies of the proofs, no? And in the proof, we will be adapting, or we will be using a theorem from number theory, which is what we call as the division algorithm. So basically, the division algorithm simply asks you to divide an integer n by a positive integer d. Kapag nag-divide ka ng n by d, laging may nakukuha kang dalawang number na q at r. Unit q, no? Si q yung quotient at si r ay yung remainder. Nagiging unique sila dahil dito sa condition ng remainder. Ang remainder kasi, hindi pa pwedeng umabot ng n. At least 0, pero at most, n minus 1 siya. Okay? Naintindihan ninyo? Halimbawa, magbibigay ako sa inyo ng example. Give me the quotient and give me the remainder. Halimbawa, ang n ko 40, ang divisor ko kunwari ay, ano ba magandang divisor? 6. Sige nga. What's the value of q and what's the value of r? If n is 40, the divisor is 6, what's the quotient? Okay, 6 and 4 respectively. Very good kayo dyan. Kasi ang 40 ay 6 times 6 plus 4. Very good. Okay. What if n is negative 40 and d is 6? What is the quotient and what is the remainder? Okay. Ano sagot? Negative 4? Ba't naging negative 4? Tama ba yun? Check nyo, dapat ito yung totoo. Isang remainder, dapat ganyan. Hindi aabot sa divisor. Ang remainder pa pwede bang maging negative? Hindi pa pwede, ha? Hindi pa pwede maging negative ang remainder. Ang remainder 0 or hanggang less than d. At least 0 but less than d. So anong quotient? Nalito na kayo, negative lang ngayon. Kasi nasanay kayo sa pangbatang math, the moment you learned about division, ang mga dinidivide positive na yung ina-apply yung division algorithm positive. Pag negative, may konting twist. Anong quotient at remainder when you divide negative 40 by 6? Hindi negative 6 ang quotient. Ano? Ayan, tama si Krisha. Ang quotient daw ay -7, ang remainder ay 2. There will only be one value of Q that will ensure R to fall within this interval. No? And that value of Q should be -7. Kasi kailangan mo maging positive ang remainder or 0, kailangan mong lagpasan ng konti yung -40. Kaya ang ipang-multiply mo ay -7 sa 6 para -42. Pag nag-add ako ngayon ng 2, magiging -40. Lalagpasan mo ng konti yung 40 for the first time. Tapos, yeah, para ang remainder mo, mapilit mong positive 2. Kaya kapag ang integer ay -40, ang divisor mo 6, hindi totoong -6 ang quotient, ha? Ang quotient ay -7, ang remainder ay 2. Kasi the remainder has to always satisfy this. Walang remainder ang mas mababa sa 0. Otherwise, it's what? It's crazy to call it a remainder na kung mas maliit siya sa 0. Okay? Naintindihan ba yung pagkuha ng quotient at remainder? Sige. Let's go back to the theorems. Pag na-prove natin to, we will stop muna. Subgroups of cyclic groups are cyclic. Paano ba ito pinoprove? So, wala nga ang proof dito sa slide. So, maybe I will just write. Ang tamad ko kasi mag-type dito. So, let's just write it. Let G be a cyclic group. At ko yung board ko sa dalawa para ma-maximize natin yung space. Ha? Okay? Siyempre, kapag cyclic group, may generator. Sabihin lang natin, generated by an element A. Okay? Anong ipaprove natin? Every subgroup of G must be cyclic. So, kukuha tayo ng arbitrary na subgroup. Let H be a subgroup of G. Anong kailangan natin ipakita? Ang kailangan mo ipakita, makahanap tayo ng generator for H. Kailangan makakuha tayo ng G somewhere so that si H ay gine-generate si G ay gine-generate si H. Okay? Yan yung ating kailangan mapakita. Okay. Where do we begin? I will begin with this. Kapag si H ay subgroup ni G, hahatiin ko sa dalawang case. Case 1. Paano kapag si H ay yung trivial na subgroup? Wala siyang ibang laman maliban sa identity. In this case, we are done. Kasi si H ay pag singleton, siya lang mismo yung gina-generate ng identity. So, take G to be. Yung G na hinahanap natin is just E. Naintindihan ninyo? Kapag trivial yung subgroup, automatic cyclic subgroup siya. Ang generator niya ay yung identity. So, there's nothing much about this case. So, case 2, H is not the trivial subgroup. So, in other words, H has more than one element. Ito yung case where H has more than one element. Tama ba? Tama? Okay. Ang gagawin natin dito, I will consider now an element A. Oh, I don't want to use A. Si A nga pala yung generator ng buong group, no? Okay. So, consider now an element, ano ba magandang letter? Naubusan ako letter. An element B in H that is not E. Kasi, may element maliban sa A because H is a subgroup, not the trivial one. So there must be another element in H. Let's call it B. Since H is a subgroup of G, then si B mismo ay nasa G. Kasi G generate ni A. So, ibig sabihin, well, lahat ng elements ng G ay powers ng A. And that will include B because B is in H and H is a subset of G. So, B is a power of A. Let's say A to the K for some K in Z. Also, by closure, A to the minus K is in H. Hindi lang si A to the K, which is bilang na kay H, pati yung A to the minus K kasi siya yung inverse ng A to the K. Right? By closure in the subgroup, yung dalawang yan ay nasa H. Now, take note that 1 of K or minus K is positive. Hindi natin alam kung sino yung positive dyan, basta isa sa kanila ay positive. Naintindihan nyo? Hindi natin pwede sabihin si K ay positive. Wala naman, diba kung negative 2 kasi ito? O kung negative 2 si K, yung minus K ang positive 2. Kaya isa dito sa dalawa ang may positive na exponent. Correct? Ang gagawin natin, consider the set of all integers K so that A to the K is in H. No, not integers. The set of all positive integers K so that A to the K is in H. Kasi kapag si A to the K nasa H na, automatic na yung A to the minus K nasa H din. So let's just consider the positive exponents. Okay? Naintindihan nyo? Titignan natin yung mga powers ng A, mga positive powers ng A na makakapasok sa H. Okay? What can we say about this set? This set is non-empty kasi si B ay nasa H and B is a power. Isa dito ay nasa H, di ba? So ito ay hindi empty. So by the previous statement, previous paragraph. Ngayon, if I have a non-empty set of positive integers, what does it have? Pag meron akong sangkaterbang mga positive integers, what does it have? Ang sure na meron siyang pinakamaliit. Anong tawag dun sa property na yon? Anong tawag sa property na yon? Ano yun? Any non-empty set, naku, magta-time na, of positive integers as a least element. Okay, anong tawag dito sa principle na ito sa number theory? Ayan lang pala, may sagot. Well-ordering principle. So basically, I am applying the well-ordering principle. By the well-ordering principle, there is a least element. Ano mo, wala kasing pangalan yung set na to eh. Ako na rin, itong set na to ay S. S has a least element, say M. Ano si M? How do you describe M? M is the smallest positive exponent so that A to the M is in H. Kasi remember, ganito yung picture. Ito yung G. Ang laman ng G, mga powers ng A. Mga powers ng A yan. So kung ito ay subgroup, ang laman ng H ay mga powers din ng A, pero hindi lahat. Posibleng hindi lahat. So yung pinakamaliit na exponent, yung kauna-unahang positive power ni A na nasa H, yun yung M. Mali. Yung exponent nung kauna-unahang power ng A, positive power ng A na nakapasok sa H, yun yung M. Halimbawa, si A yung generator. Si generator wala sa H. Nung pinatakbo to, a squared, a cubed, a to the fourth, pumasok yung a to the fourth dito for the first time. Okay, tapos lumabas yung a to the fifth. Si a to the eighth, nandito ulit. Yung kauna-unahang exponent, yun yung 4, yung m. Naintindihan niya yun yung m. At tinutukoy natin sa well-ordering principle. Now, ano bang gagawin natin dyan sa m na yan? Let G be a to the m. Ipapakita ko na yung a to the m na yan na sinasabi ng well-ordering principle na nag-exist, ipapakita ko yung a to the m na yan, i-generate niya yung h. Kasi diba, remember, ang ating goal ay maghanap ng element ng group na mag-generate sa subgroup na h. Ang aking hinala, ang mag-generate sa h ay yung a to the m, where m is the smallest positive integer so that a to the m is in h. In short, kung sino yung kauna-unahang positive power ng a na makakapasok sa h, siya yung mag-generate kay h. Yun yung aking hula. So ito na yung aking ipoprove. I just need to show that every element of h is a power of g. How do we do that? We will take an arbitrary element of h, say little h. Since h is a subset of g, subgroup of g or subset of g, doesn't matter, then h itself is a power of a. But we don't know what exponent that is. Now let's say a to the n for some n. I need to make it faster, no? Kasi tayo magta-time na. For some integer n. Ang gagawin ko ngayon, yung m na ito, i-divide ko sa m. Kukunin ko yung quotient, kukunin ko yung remainder. Okay? Ba't ko gagawin yun? Tignan niyo yung mangyayari ha pag ginawa ko yun. So let me erase this. Clear page. Okay. So let's continue. Okay. Ito yung previous na saan tayo natapos dyan. Ang gagawin ko next, di-divide ko yung n by m. Okay, let's divide. By division algorithm, there exist unique integers q and r such that, ano yung katotohanan? Si n, pag dinivide sa m, may quotient ka na q, may remainder na r. Anong totoo about r? R is at least 0 but less than m. The divisor is m. Dinivide ko si n by m. Bakit ko gagawin yun? Kasi, di ba si little h ay a to the n? Tama ba ako? Si little h ay a to the n. Remember, I need to show that every element of h is a power of g. Kaya kumuha ko ng h at capital H. I need to show that h will be a power of g. How do I do that? I started with this. Tapos, yung a to the n na yan, isusulat mo as a to the mq plus r. Laws of exponents once again. This is a to the m to the q times a to the r. Kung mapapansin nyo, si a to the m siya si g. G to the q times a to the r. So, you know, ang nangyari, we're almost done, except, tignan nyo, si h ay power na ng g, kaya lang may asungot dito. Meron nakalagay na a to the r dyan. Ang gusto ko ipakita, h is actually g to the q. So, I want a to the r to vanish. Paano mawawala yung a to the r dyan? We will show that r is in fact 0. Kasi kapag ang r ay 0, identity yung a to the r, si h ngayon ay power na ng g, and we are done. Oh my God, para ko hinahabol ng demonyo. 4 minutes na lang. Magta-time na. Okay, paano gagawin yun? Ganito. Pag meron akong, di ba sa group theory, pag meron akong h, g to the q, a to the r, how do I solve for a to the r? Para kang merong equation. Ano ba h yan, di ba? Para kang may ax is equal to b. Paano nga sinasolve to sa groups? Di ba? A inverse times b. Ganyan siya, di ba? Yan yung formula natin. Yung linear equation, unique solution. Ito yung formula. Okay. So how do you express A to the R in terms of H and G to the Q? It's basically the inverse of, I'm sorry, ano mas maganda? Hindi. Dapat yung inverse ng G to the Q ang i-multiply ko. O whichever. Ano bang tama? Ang isasolve ko ay A to the R. So A to the R ay G to the minus Q times H. Tama ba from this equation? So A to the R ay G to the minus Q times H. Nag-multiply ako ng G to the minus Q on both sides. Okay, ganito. Nasa na si G? Where is G? G is, from the previous slide, G is A to the M. And A to the M is in H. Siya yung kauna-unahan to be in H, diba? So G is in H. So lahat ng powers ng G nasa H kasi si H ay subgroup. So itong buong power niya na kay H. And as given, si H ay nasa capital H din. Diba? Ayun. So yung product na ito, because H is a subgroup, must be an element of H. Tama? So ano napatunayan natin? Si A to the R ay nasa H. Note that R can be positive since if it was positive, ano mangyayari? Hindi siya 0 pero less than D siya. Ano mangyayari? R will be smaller than D and, but D? M pala tayo. Ang divisor ay M. If it was positive, mas maliit siya sa M pero yung A to the R nakapasok sa H. It will contradict the definition of M. Kasi ang definition natin ng M, si M yung pinakamaliit so that si A to the M ay pasok sa H. Ang mangyayari kapag si R ay positive, si A to the R makakapasok sa H, mas maliit siya kay M. This will contradict the minimality of M. Sabi natin si M na yung least, pinakamaliit so that A to the M is in H. Diba? So that will contradict. So hindi pa pwedeng maging positive si R. Ano na lang ang pwede kay R? Ayun, sa case na ito, ang pwede na lang, R must be 0. And when R is 0, ano si H? G to the Q times A to the 0, G to the Q times the identity, which is G to the Q. Ano na patunayan ko? Lahat ng element ng H ay power lang ng G. So therefore, I was able to prove that the subgroup H can be generated by G. And because H was taken arbitrarily as a subgroup of G, napakita ko na yung subgroup na yun is also cyclic as it was generated by a single element. Nakita niyo yung proof hindi masyadong madali, no? In fact, you have to go over the proof several times to actually understand it piece by piece or line by line. So today, before the end of the meeting, we established the fact that cyclic, ano muna yung dalawa? Kapag ang cyclic group infinite, isomorphic sa Z. Pag finite, order N, isomorphic to Z sub N. Pangatlo, ang subgroups ng cyclic groups, lahat cyclic. Titignan natin yung mga consequences na itong magaganda next time. I'm sorry, nag-exceed na tayo ng time. I'm going to stop the recording now.